And rule number 4. Whoa, that's fun. Okay, we're having problems right now. All right. Rule number 4 is the derivative of a sum or a difference. Now it's saying, what happens if you have two different functions and you're adding them up? Well, if you're just adding or subtracting them, you can think of them separately. This is what the rule says. If I'm adding or subtracting them, I can think of each one separate and do the derivative of each one separate. So if I had x cubed plus x squared, okay, that's like saying my f of x is x cubed and my g of x is x squared. I'm adding two different functions. What this rule is telling us, we can do the derivative of just the first one on its own, 3x squared, and we can do the derivative of the second one, x squared will be 2x. So we've got, here's our derivative of our yellow one, here's our derivative of our blue one. It's important to show this because we're going to find out later that if we multiply things, it doesn't work out nice like this. But adding and subtracting does. If we add or we subtract, it's like we thought. Derivative of the first one, derivative of the second one. Yeah. Okay. So even if we have complicated long ones, right? This one, how long would this take with the definition of the derivative? Too long, exactly. Now with all of our rules combined, since we're just adding and subtracting, we can do each of these derivatives on their own. What's the derivative of the first one going to be? 15x to the 4. Derivative of the second one, 8x cubed minus 14x plus, what's the derivative of just x? 1. So whenever you have like 5x, the derivative will just be 5. 7x, the derivative will just be 7. And then the constant at the end, the derivative will be 0, so you don't have to write anything. Okay? Done. One line. If I think of it, you probably haven't had questions that you could just look at and write the answer probably since grade 9. Right? And now we get to what's supposedly the most advanced thing of high school, or even most people don't even get to calculus, and we're back to look at the question, write the answer. And if you don't know the rules, you look impressive. Like, whoa, you could just do that? And you're like, yeah, right? So if someone's impressed, don't tell them how to do it. Just let them stay impressed. For this second one, we do have to take some preliminaries to change this into the power rule so we can apply it. Square root of x is x to the half. That x cubed on the bottom can be brought to the top and become x to the minus 3. So now that they're all in the form that we know how to do the power rule, we can just go directly to the end. With the negatives, you've got to be a little bit more careful because that's, people make more mistakes when they're dealing with negatives. So just be careful that you make sure you subtract 1 from the exponent. And that negative 3 goes in front to that negative 5 becomes positive 15. But the nice thing is that we can just write our answer straightforward. So here's number C. Try this one on your own. Woo. Okay? With your new skills, you can show people derivatives at parties and make new friends. Totally. right? Yeah, have you had your year-end football party yet? Perfect time to put it up there. Look what I learned in math today. So there's our preliminary step. I changed any x's that were in the denominators to negative exponents. I took all my radicals and changed them to rational exponents. Some of them I had to change them to rational exponents and then make them negative exponents. But now it's just a matter of oh man. See the negative here? There you go. How did you do? Once you're done checking this one, try the next one, see if you can work backwards. If there were two terms, what would it have been originally? Oh, I like this one. So part of the strategy, we only have one rule so far, and that rule is for exponents with powers. And then with that rule, we extended it to say, oh, if it's a constant in front, it doesn't affect the rule. If you're adding and subtracting multiple things, it doesn't affect the rule. So we've learned one rule and a bunch of places where we can use it. In this case, this doesn't look like a format of where we could use that rule. However, we have algebra skills. We could take extra time to multiply this out. If we did that, oh no. If we did that, minus 4x minus 6, yes. If we multiplied it out, we change it to look like something we can work with, and now we can take the derivative. And again, we notice the thing that we saw right at the beginning. What happens when you take the derivative of a parabola? You get a line. So even if it's a complicated parabola, we get a line. And I saw some of you already worked on the working backwards. For me, one of the things for working backwards at this stage that I find helpful, I say, well, I have an x to the 3, so that means I had to have an x to the 4 before that. What number would I have to have in front in order for it later to become a 20? It would have to be a 5. So that's sort of the strategy that I use when working backwards. I start with my exponent, and then I look at my number in front. And if I just had a 5, it would be 5x. Again, these ones, when doing the derivative of this, probably you're going to eventually just say, oh, 5x is 5, 12x is 12. But it's still following the power rule, because what's the exponent? It's a 1. What happens when I bring that 1 out in front? I get 5, and then I'm going to subtract 1 from the exponent, and I'll get x to the 0, and x to the 0 is equal to 1, so you get 5. But you'll go directly from derivative of 5x is 5, and so on. So there's some practice questions there at the bottom.